So we're going to do Unit 5 review as video. Multiple choice 1 in the accompanying diagram, lines A and B are parallel, so we know that this is true. Lines C and D are transversals, and I want to know which angle is congruent to angle 8. Well, angle 8 is right here. In terms of congruent, I noticed that 6 is an alternate interior angle, so angle 6 would be my answer. On the second one, I'm looking for mean proportionals. I've got one of those geometric means and extremes problems where AC is this whole piece, and that's this, and AD is this part of that piece, which basically says I've got an entire hypotenuse and then a part of that hypotenuse. So which side would actually complete both of those triangles? And hopefully you realize that if I wanted to complete triangle with the AC, it'd be ABC. And if I were to complete the triangle that's in green, I would have ABD. Well, the geometric mean then happens to be the leg, which would be AB. So AB would have to be in the diagonal between the whole hypotenuse and the part of the hypotenuse that's attached to it. Number 3, in the accompanying diagram, JK is the mid-segment of MNO. What is true about JK? Well, a mid-segment means that it makes the two pieces of that segment congruent. And we've learned that mid-segments happen to be half of their bases. So we know that JK is going to be 1/2 of MN. Is that a choice up here? And it is not. So then what else do you know? Well, the mid-segment is also parallel to its base. Is that a choice? And it is. So number 3 should be choice 4. Number 4, which of the following is true for similar triangles? Well, corresponding sides are never congruent. They're always proportional. So this is definitely gone. This is true. But let's see. I'm sorry, not corresponding angles. That's not true. Sorry. This is true. Corresponding sides are proportional, not congruent. Angles are always congruent. It's not all of the above. It's just choice 3. If two lines are parallel to a third line, well, if I've got two lines that are parallel to a third line, if this line is parallel to this line, these lines all better be parallel to each other. This can only be choice 1. The ratio of the sides, if we're dealing with sides, it's a segment, is 2 to 3. What's the ratio of the medians? Well, the medians are just segments, which means it's going to be the exact same thing as the sides. And there's your answer, 2 to 3 as well. In the accompanying diagram, line M is parallel to line P. So we know that this is true. Line T is a transversal. The measure of A is 3x plus 12. The measure of B is 2x plus 13. Well, what's the value of x? Well, these guys are not congruent, but it turns out that A corresponds to this guy, which means A and B must add up to 180. So then if we set up the equation, we know that 5x, I'm combining like terms, plus 25 is 180. Subtract 25 on both sides. 5x is 155. Divide both sides by 5, and x is 31. Remember, you've got your calculators. Number 8, BC is a mid-segment. You know that because you're shown that this particular side and this particular side have those midpoints B and C respectively. So we know that the mid-segment is half of the base. So you can either take half of the big side equal to x plus 4, or I think what's easier is if you double the short piece, it's going to be equal to the long piece. So then the algebra here becomes 2x plus 8 equals 3x plus 4. If you subtract 2x on both sides, you get x. If you subtract 4 on both sides, you get 4. And there's your answer. Okay. Write a similarity statement and identify the theorem that justifies a similarity. The idea is we're probably looking for side, side, side. So we have to find out if the sides are proportional. So what we're going to do here is we're going to take a look at each of the sides. The smallest side in this triangle is 10. The smallest side in this triangle is 12. So 10 to 12 simplifies to 5/6 ratio. The middle side then would be 15 to 18. And 15 to 18 simplifies to 5 and 6. And then 20 and 24, again, you can be doing this all on your calculator, typing in those numbers, math, fraction, enter. This also becomes 5/6. So these triangles are definitely similar by side, 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 just a matter of naming them. So one name you could do would be triangle EFJ is similar to triangle RFQ, and that's going to be by SSS similarity. The next one, the figure below, MN and AC are parallel, and we're going to use that for this next problem. It doesn't say MN is a midsegment, so you can't think that. But if AM is 4 and MB is 8 and BC is 36, I want you to find BN. So one thing that I probably would do is say, well, this whole side then would be 12. Add up those pieces, and I make a proportion that would look similar to this. I would say 8 is to 12. The top part of the left is to the whole left, as the top part of the whole of the x, the top part of the right, x, is to the whole right. Cross multiply and solve, and you get 12x equals 288. Divide both sides by 12, and you should end up being with x being 24. The next part changes some pieces. So let's change these guys. So now we've got AM to be 3, AC is 15, MB is 6. What's MN? Here's where you have to be careful because you're dealing with bottoms, and bottoms have complete sides. So when you do this problem, you could say that yellow side is to yellow bottom, as green side, 6 plus 3, is to green bottom. And then cross multiply here, you get 9x equals to 90, and x equals 10. Let's go to 12. In the figure, ST and U are midpoints. RU is x squared, which means UQ is x squared. ST is 6x plus 16. So this guy right here is 6x plus 16. It wants you to find UQ. Well, the fact that you know that all those little points are midpoints, you have a mid-segment. And remember, the mid-segment is equal to half of the base. So you really can just say, you can really just say that one of these x squareds is equal to 6x plus 16, right? And then at that point, you've got to set this thing up as a quadratic, set it equal to 0. X squared minus 6x minus 16 equal to 0. Factor x minus 8, x plus 2, x equals 8, x equals negative 2. You're going to have to throw out the negative 2 in this case, and you're just going to leave it as the 8, and then you're going to get UQ is 64. Okay. Determine the value of the variable, simplify any radical answers. We've got a leg happening here. And again, some of you guys might want to use highlighters. This leg is a part of this whole thing, and this leg is a part of this piece. So the leg is the mean proportional, the geometric mean between the whole hypotenuse and the part of the hypotenuse attached to that leg. X squared equals 84. And I'm actually going to look in this case at what I've cross multiplied here. So I've got x squared being 6 times 14 or 84, which means x is going to be equal to the square root. Let's see, x equals radical 4 times radical 21. So x equals 2 root 21. You've got to decide if you're going to factor tree it or if you're going to actually find the largest perfect square that divides evenly. So go to the next one. Here you've got an altitude piece working in here. So you know that you've got 6 with the x and 6 with the x plus 5. So we can set this one up as 6 over x equals x plus 5 over 6. When you cross multiply, you need to distribute. X squared plus 5x equals 36. Subtract 36, set it equal to 0. X plus 9, x minus 4, because you got to factor it out. X is negative 9, x equals 4. So if x equals 4, I've got this to be 4, and I've got this is 4 plus 5, or this is 9. And that then means that my whole hypotenuse is 13. Now I can work with the leg theorem, and I can say why my leg theorem is going to be with my whole hypotenuse of 13 and the part of the hypotenuse attached to that leg. This now becomes y squared equals 52. But one thing to notice, this cross product, 4 happens to be a perfect square. So y is going to be the square root of 4, which is 2 times the square root of 13. Okay, so then for the last one, which is the proof, we are given that we've got perpendicular lines, and we're given that we've got some cross products being equal. Well, if cross products are going to be equal, then we know that we must have had a ratio, sides being proportional, and if sides are proportional, then you know you must have some similar triangles. So let's take a look at where these right angles are. BC and AF. It's probably going to be the right angle there, and then FD and AB, it looks like we're going to be the right angle here. The triangles it looks like that we're going to be pulling out are going to be these ones. It's going to be, here's your right angle at D, and this is going to be A and F. And then here's the other one with the right angle at C, which is going to be B and A. Okay, so we're going to run out a lot of room here, so let's see what we can do. Statement reasons. So we've got one, BC perpendicular to AF, FD perpendicular to AB. This is given. We need to use 3 letters to name these angles, since there's more than one angle at either right angle. Or what we could do, if you want, is I'm going to call this angle 1, I'm going to call this angle 2, and I'm going to say angle 1 is congruent to angle 2, and then this is because perpendicular lines form congruent right angles. Now I've got to see something else, and I notice that this angle A right here is a part of both triangles. It happens to be here as well as here. So we can then say angle A is congruent to angle A, and that's going to be because of the reflexive property. So we have enough to talk about angle-angle similarity, just a matter of naming those triangles. So I'm going to name the triangles ADF. Oops, not congruent. We are in similarity. So ADF is going to be similar to triangle ACB. And now what's left to do is to figure out how we're going to set up our proportion. So our cross products are equal. And I'm going to go like this. I'm going to say that I'm going to go that FA is to BA as FD is to BC. No particular reason, but I'm matching up those pieces. And that's going to be, I don't know why that says 10. This should be 5. And then this is going to be similar triangles have sides in proportion. You can use a different wording than me. It's not a big deal. And now when I start cross multiplying those sides, I'm going to get BA times FD, 6. BA times, and they actually have it as DF, so BA times DF, and that should be okay, just have this in a different order, is going to be equal to FA, or AF, is how they have it, AF times BC. And then this is cross products are equal. All right, so there you go. Hopefully that will be helpful. Okay,